Hello everyone, I'm back for my daily coding series. Today is day 79. So I'm just going to pick a practice problem here. Maybe I could try like a harder one, like a graph or dynamic programming. Let's see. Or maybe I could try a backtracking problem this time. So let's look at matchsticks to square. Okay, so I have not looked at this yet. So let's see. You are given an integer array matchsticks, where matchsticks of I is the length of the ith matchstick. You want to use all the matchsticks to make up one square. You should not break any one stick, but you can link them up, and each matchstick must be used exactly one time. Okay, so how do I disable this? I don't think that worked, but okay, so what is a square? So a square is 4 sides of equal length. So basically we have to figure out a way to divide these matchsticks into 4 equal lengths. So we know, so in order for this to be true, the sum of matchsticks must be equally divisible by 4. Right, so here is 2, 4, 6, 7, 8. Here is 3, 6, 9, 12, 14. Is this this would be 16, right? That's 12. Yeah, so this is 16, but it seems that there's no way to evenly divide it. So first we could check. So before I'm not going to code yet, but we know that if sum of lengths is not evenly divisible by 4, then it is false. Okay, so otherwise start the problem. So the problem will assume that okay, so let me just give variable names here. I'm not going to really start coding yet, but let's say that side length is equal to, well, first of all, let's say if we'll say total is the sum of matchsticks, and then we'll say if total mod 4 does not equal 0, we can return false. Side length equals total integer division by 4. So this means like it can't evenly be broken up into 4 sides, and then this is the side length. So now we need to basically divide the array into 4 pieces of side length. So that's just sort of like the bases out of the way. So okay, so next divide matchsticks into 4 side length. I guess I'll say into 4 pieces or sides, but I'll say pieces because it's an array. Into 4 pieces of, I guess I could say, with some side length. And it's almost like partitions. So we're dividing it into 4 partitions with sum of side length. I'm also wondering if we could benefit from sorting the sides. And the sides cannot be negative, obviously. Okay, so my question is sort or not? And then also like how to brute force. And then maybe if we can use a decision tree. Okay, so let's look at the first example. So it seems that these two examples are both sorted. I'm not it may just, we may be able to infer more easily if something's sorted, but it may not necessarily be a strict requirement. So if you look at the first one, 1 2 2 2, so the total here, so total, I'm going to draw it above. So total here, like I said, is equal to 8. So that means side length is equal to 8 divided by 2, which is 4. No, 8 divided by 4, which equals 2. So we want every side to be 2. So yeah, so I think what we do is basically we find we need to make a side of length 2. And then, so we need to make a side of length 2. So for instance, we'd calculate that 1 and 1 is length 2. And then we need to say, so okay, so then we're going to make 3 side lengths out of 2, 2, 2. And then once we get that of 2, so we'll have 1, 1, and then 2. And then we'll say, okay, we need to make 2 side lengths out of 2, 2. So I think what we could have is sort of like a function, I'll call it backtrack, I guess. And in that function, we want to, so every time it gets called, it's going to have like sides that we need. So when it gets called, it's going to have the number of sides remaining, and then like the match, I guess I'll call it sticks. So like the sticks left, and then we'll call its width 4 and matchsticks. And then basically what we would do is just keep going until we make a length of side 2. Okay. So in this case it works because it's nice and even, but what if we consider a different situation if it was like 3, 2, 2, 1. Okay, so this sums up to 4, 6, 8. So this is actually not possible. So we also must assert that, so I'm noticing like no one piece can be bigger than the side length. So if that's true, we should also return false. So so like if the max of matchsticks is greater than, well, I guess we could have side length here. So if the maximum of matchsticks is greater than side length, then return false. And here we're using max, but it really just means if any element in matchsticks is greater than side length, but it's advantageous, like the max is the most likely to be greater than side length, and since we only need one, we can just look at the max. So this is like another, so now we can assume that all of them must be less than or equal to side length. Yeah. Okay. So in that case, this example would get pruned out. So okay, so then let's look at the second case then. So 3, 3, 3, 3, 4. So here the total is, let's see, 16. So side length then is 4 because it's 16 divided by 4. Sorry, let me just silence my cell phone for a second. Okay. So in this case, okay, so we'd keep, so in this case, right, so we need 4 sides left and we're given matchsticks. So we'd like keep going until we make 6. or 4, I guess. So the only way that 3 can be a side, so this is also interesting, like the only way that 3 could be a side is if a 1 exists. And the only way that if we had 1, if that could be a side, is that if something else sums up to 3. Yeah, so another way of solving this problem, I guess, would be like build one side. Now that I was gonna say like build one side 4 times and then just like remove the pieces that you use every time, but that, and then do all those combinations. But I think there's probably a simpler approach. So this is where sorting might be useful. Okay, so what if we had, let's say 1, 2, 2, 3. So if we had 1, 2, 2, 3, let's say 4, 4. Okay, so this would work. You would want to do these, and then these by themselves. So I guess if we think, maybe I should think about it as a decision tree. Like maybe we should start, instead of a top down, like where we start with 4. Because I like this idea of like, okay, we found a side, so now we have to make three more sides. But I feel like there may need to be another function within that actually does the backtracking. So we're basically forming a partition. So it could be in any order. So that means we can, at every step, we could either include or not include. So we'll start with like empty lists. And then on the left of that, we would have 1. And on the right, we would have nothing. And then on the left of that, we would have 1, 2. And then on the right of that, we would have just 1. And on the right of this, we would have 2. And so we would do this kind of partition. And what would the goal be here? The goal would be for us to find a side length. And then once we find the side length, we would so a thought popped in my mind that maybe like the order of these don't really matter, so it may be more effective to use a dictionary where it will be like the stick and then how many of those sticks that we have. So, okay, so what are we looking for in this case? Like, ideally what we do, I think I'm just trying to optimize too quickly. So what we would do is we would find something that equals side length. So in this case, we would get either 2, 2 or 1, 3. And once we find a side length, so this would give us like one side. So why don't we like do this until we get one side? And then when we do get one side, we can call it again, but remove all of the elements that we did. And then if we, okay, so like go until you get one side, then call the function again to find another side, but without all the sticks you used. Okay, so I'm not going to over optimize too quickly. So let's try this. So at every step, so we'll have yeah, so we can just pass it an empty array, I guess, and then we can use this matchsticks variable. So we'll have our base case, and then we'll say, so at every step, we're either going to include it or not. So we could say sticks, so we need an I as well, I suppose. So we'll just put in 0. And I'm going to put sticks at the front here. Okay. So we're going to append matchsticks of I, and then we will call the function backtrack. Still not muted, right? Okay. Then we'll call the function backtrack with, we might not need sticks, but we may. Okay, so I was thinking then we would call it with sticks for and I plus 1. And then we would pop matchsticks of I. So we'd call it one time with and one time without. Like this. And then, so what do we do? So we call it one time with and one time without. And then sticks. So then this would, so keep appending to sticks, and then it would remove it. So at every point we have a unique combination of sticks. So I guess what we could do is check if the sum, okay, so this is kind of inefficient. We could probably keep track of this while we do it, but let's not optimize too quickly. So if the sum of the sticks equals the side length, if the sum of sticks equals side length, also if I, so another base case too, if I equals the length of matchsticks, then that's like also we should return after here probably. Okay, so if it equals a side length, that means we found a side. So in this case, so if sides equals 0, then I think we return true. Or maybe if it equals like 1. Otherwise, maybe we could add that as a separate base case. So if we ever call this function with sides equals 0, then we'll return true. Okay. So if we find a side length, then I'm thinking we want to do something like, let's call this again with matchsticks. So we'll basically restart with a fresh set of matchsticks, or I guess maybe an empty list instead. And then sides will be sides minus 1, and then I will be reset to 0. So what I'm thinking is, then we'll return that. And then I guess if we got to the end, we would return false. Okay, so what I'm thinking, whoops, sorry. Okay, so what I'm thinking is sides will be, if we ever call this function with sides equals 0, then that means we found 4 sides. Well, and sticks has to be empty. Well, maybe not sticks, but maybe matchsticks. So what if we remove, okay, so this is a little complicated, but I'm thinking that my initial idea was, so once we find a side, we want to remove those two from matchsticks. So we may need to like throw some copies around. Because we don't want to do it here, but only maybe here. So maybe it should take in like starting sticks or something like that. And then we'll send in matchsticks. And then so here we'll use, so now I'm thinking, so here we'll do matchsticks, but first we want to say we could say for like stick in sticks, matchsticks dot remove stick. So this is sort of my idea. So when we find a valid side, we're going to remove everything in matchsticks, and then maybe we can optimize this later. But so when we find a valid side, we will remove every stick from matchsticks, which is like the original sticks that were given. And then we'll call backtrack again with the new matchsticks. Okay, and so in our base case scenario, if sides is 0 and we have no more sticks left, then we can return true. I think maybe something, so if not starting sticks, return true, otherwise return false. So if we get to the end and we have size, so this is theoretically actually impossible because of the constraints that we set up. If we're at sides equals 0, that means we have 4 sides of exactly side length. So if false ever triggered here, it means it should have triggered there. But I'll just keep it for now. But the idea is if we get to sides equals 0 and we get to starting sticks being empty, then that's good. That's our that means we can do the problem. If the sum of sticks, so this is just for like one side, I guess. So if everything that we've chosen for a side equals a side length, then we remove everything in matchsticks. But what if like this side isn't valid? Maybe we should send a copy there. Or maybe we should just like add them back. Yeah, it's maybe instead of returning, because I'm thinking like if this ends up not being valid, then we want to undo that change to get to the next combination. Okay, so I'm going to, and then so sticks. Okay, so let me just look at this one more time. So matchsticks starts as starting sticks. I'm not sure if we need the copy if we're removing it and then adding it back. Okay. So we start with starting sticks. So none of these will trigger. And then at every step, we're adding a stick and then removing a stick. And then basically the idea is if we get a side, then we remove all of that and keep going. And then here I'll just say reached end. And then maybe instead of matchsticks, we want to say starting sticks here. Let me just make sure matchsticks. So matchsticks should only be within this context. Okay. All right, let me just try running it and seeing how it fails. Okay, missed a colon. Okay, missing a required argument I. Oh, yeah, it's because I also do starting sticks. So this is like the side, and this is, I think you just send the same starting sticks. I think I should more rigidly define like what starting sticks is versus side. Okay, so missing, where is that line? 37. Yeah, so what should sticks be? Empty, I guess. Okay. See if we get through the errors. We're popping out of range. Okay, so here I have if I equals length. Reached end of. So ideally, or like initially what I'm thinking is if I equals the length of starting sticks, then we should not be I wonder if there's a way to do this like without backtracking. Like by just sorting. And just saying like, can I make 4 groups of side length? Well, like it's almost like a two sum. Well, not two sum because it could be. So it is like 1, and then I need to find a 3 somewhere in here. Like something that sums to 3. I think that might be a better way of looking at it. But yeah, so I'm gonna call this video here because it's at almost 30 minutes. So thank you guys for watching. I wasn't able to solve this one today, but I think I had a lot of good thoughts, but maybe I tunneled too much into coding a solution before I really understood what the full problem, and maybe just thinking of an algorithm that would have translated into code more easily would have been a better approach. But thank you guys for watching. That was day 79, I think. So I'll see you tomorrow for day 80.